Okay, this is Unit 10, Objective 2. We are looking at converting equations between rectangular and polar forms. And you have at the top a kind of quick review of some of the concepts we looked at in 10.1, as well as some things we looked at last semester or earlier this semester. So first up we have the relationships that exist between rectangular and polar. So you have your x squared plus y squared equals r squared, and your tangent theta equals y over x, which is what we used to convert rectangular points to polar points. And then we have our two cosine and sine relationships, which is what we used to convert polar points into rectangular points. They're going to have, I'd say, very similar applications within what we're going to be doing today, although instead of doing coordinate points for our conversions, we're going to be doing entire equations for our conversions. And so each of these is used in different ways. X squared plus y squared equals r squared. I would say this one you will be looking to use primarily when you got what looks like a polar equation. You're trying to get it into a rectangular equation. And so ideally speaking, you are going to be looking to somehow get r squared inside of your equation. So that could be multiplying something by r, or potentially squaring both sides of the equals, something like that, and you'll see those today. But you're looking to get r squared so you can substitute. Okay. Similarly, tangent theta equals y over x. We use that, I would say, especially speaking, converting from polar into rectangular, because we'd be looking usually to use this when there is no r. So potentially speaking, you've got some sort of equation that relates cosecant theta or something along those lines. And again, you'll see this model in a bit, but we use that one, I'd say, especially when there's no r. And then our two middle ones here are cosine and sine relationship ones. These we use in a variety of ways, but I'd say the most common way that we'll be using it today will be to substitute, especially these two, I should say, substitute for x and or y, depending on kind of what you have in your equation. Okay? The other thing that you will be making use today, and this will come more, I'd say, on the back side of this set of notes on the second page here, is some of the stuff we looked at with circles and parabolas over the course of the school year so far. So first up we have with a circle, a reminder that the translated circle with center hk and radius r has this equation: x minus h quantity squared plus y minus k quantity squared equals r squared. Referenced in 10.1 that's what this equation is. Right, it's just here our hk is at the origin, 0, 0, which is why it would 0, 0 here would simplify, right? And so if you were trying to graph this equation, you'd pull out your hk, that would be the center of your circle, and then whatever your r is back here in your r squared, whatever the r is, would be your radius, and so you'd move from the center out that radius's distance in all directions, okay? And then as we looked at graphing circles, we also at the time would have reviewed putting it into descriptive form. And so particularly, or specifically speaking in this case, we're looking at completing the square. And so we're going to do a quick little review of this. Actually two different types of complete the square. If this is something that you're sitting there going, ooh, that was a little rough after watching one or two of them, then maybe pause the video before you proceed into the meat of this lesson with converting equations. Pause the video. There's an extra help video made just of completing the square. Crank out a couple more of those, right? Re-solidify that understanding, and then come back to the video once you're good with complete the square, because you will have to do this within the course of the lesson. Not every time, but you want to make sure you're good to go. Okay? So quick review of completing the square. We have x squared plus y squared minus 6y equals 15. This is the one for those who learned it this way, where you are separating your x's from your y's. And if we had had another coefficient over here with the x's and y's, we'd subtract it over with the 15 on the other side. And you're looking for what goes in this blank back here behind. And you always find what that number is by halving this number, so it'd be -3 if we cut -6 in half, and squaring that. So -3 squared would be 9. But if we add 9 to one side of the equation, well, that has now modified that left side. We have to keep it equal on both sides. So if we're going to add 9 to one side, we have to add 9 to the other, which this will now allow us to factor. There's no other x's, so that's just x squared. And back here we have y squared minus 6y plus 9, which factors to y minus 3 quantity squared. And that's why we do the difference of two squareds. Or sorry, completing the square. I apologize. Okay, that's why we do completing the squares, to get our y minus 3 quantity squared. Okay, and then at the back we have 15 plus 9, which is 24, and so you could write 24 there, but technically speaking, because again I kind of have that knowledge of where we're headed, since we are going to be graphing this, it'd be handy to know what that is r squared, so we know what our radius is. So instead of writing 24, I'm going to write root 24 squared, which is the same thing, right? The squared and the square root would simplify. That will allow me to see the r. I could even simplify this a little bit further if I wanted to 2 root 6, whichever one you're more comfortable with. Personally, I'd probably leave it as root 24. Okay? So we're going to do another complete the square here in a bit, just to, again, give us another go with it. But quick reminder about parabolas, which is the other thing that will come into play within the course of this lesson. The translated parabola with vertex HK down here, and stretch A, right, which is again that up and over that we've got, has the equation y minus k equals a on the outside, x minus h quantity squared, and if the a is negative, that turns that parabola upside down. Okay? And so if you were to graph this, you'd pull out your HK, your vertex, and then some people think of it as moving A, others think of it as plugging in points, doing kind of an XYT chart to get the rest of their points. Whichever one is your preference is up to you. Okay? But again, reviewing the complete the square idea with this one. Okay? Here we've got our 4y equals x squared plus 8x. Okay, and then go ahead and take a moment. You heard me walk through it up above. Pause the video if you need to, but see if you can figure out what number is going into that blank for complete the square. Okay, well again, it's half of this number, so half of 8 would be positive 4, squared, which is positive 16. And again, if you add 16 to one side, you have to add 16 to the other. Okay? And then parabolas had kind of a unique look to them because we have now our 4y plus 16 equals, and this factors to x plus 4 quantity squared. We do want it to be in this form, right? Y minus k equals a times x minus h quantity squared. So the other thing that we did back in our parabola unit was look at how do I get this to just be y and not 4y? Well, that came by factoring that 4 out. So we would have 4 times y plus 4, right? If I factored the 4 out, if this was in parentheses, the 4 outside, and then dividing that 4 over to the other side. And actually, let me go ahead and show that factor step just to make sure people are good with that. Factoring the 4 out. All right, so we factored the 4 out here, y plus 4, and then divided that 4 over to the other side of our equation. And so now we're in our HK form. My H would be negative 4, my K would be negative 4, and my A would be 1/4. Okay? Okay, so again, all that was just kind of a quick refresh on completing the square. If you, like I said, are sitting there going, I don't feel so confident about that, then maybe pause the video, go over, find the extra practice video, specifically on completing the square, do a little review on that. That's fine, you've got the time, right? And then come back to this when you're ready. Okay? Okay, so for the meat of today's lesson, again, one more time, we're looking at converting between polar and rectangular equations. Okay, we have, to start us off, 4 rectangular equations that we are going to be turning into polar. And when it turns into polar, you're going to be looking to get this to either be r equals, r squared equals, or theta equals, depending on what the case may be. Honestly, for the most part, this is either going to be r equals or r squared equals. The only time we really we'll leave it as theta here, okay, is only if there is no r to solve for. Because again, for the most part, we're going to leave it in terms of r equals or r squared equals, whatever the case may be. Okay? The nice thing is that for the most part, these problems have, I'd say, very similar steps, although some of them we're going to have to kind of phrase in a very broad way. But the first thing you are going to look to do every single time, so let's go ahead and write some steps off to the side here. When it comes to changing from rectangular into polar, is to first off look to substitute. Okay? Substitute, in this case, we're usually going to be using our middle two equations here because, again, I've got rectangular, so I'm substituting for x and y, and we're going to be putting these into x or y, whatever the case may be. Okay? And so I'm going to model these steps with number 1 here. Okay, number 1, I'm going to go ahead and first substitute in for x. X, as a reminder, is r cosine theta. And so this is going to be r cosine theta squared. Okay. Y is going to be r sine theta. So r sine theta squared. Okay, and I know there are some of you who might be looking at that original equation and already making another connection. Hold on to that. I will address that in the end, but I'm going to keep going from here. Okay, so we substituted. The next thing you're going to be looking to do is to rewrite. And I know that that's a very broad step, but rewrite, this could potentially mean so simplifying in some way, shape, or form. If you have like common terms that you could combine, something along those lines. This could mean factoring in some way. If you've got a GCF you could pull out, or a difference of two squareds, or something along those lines. You might look for Pythagorean identities. So we looked at several of those over the last couple of units. So something like cosine squared plus sine squared equals 1, or one of those modified Pythagorean identities. But you're going to be looking to rewrite. What could I do to kind of clean this up, simplify it, manipulate it? And so in a problem like this one, you might be sitting there going, okay, well, what can I do? Maybe you see it immediately, maybe you don't, but if nothing else, you know, well, I know how to square things. Square things means multiply it by itself. So let's go ahead and do this squared component. What is r cosine theta squared? That would be r squared, because r times r is r, and cosine theta squared, or cosine squared theta. Same thing over here. R squared sine squared theta. Okay, and so then you pause and you look at it again. You're going, okay, what else could I do? Again, consulting our steps over here. Well, I don't see any common terms I can simplify, but factor. I do notice that I have a GCF that I can factor out in this case. Both of these terms have an r squared in common, and so I can pull that r squared out. So I'd be left with the cosine squared and the sine squared. Okay, what else can I do? I've simplified, I've factored. Oh, that's a Pythagorean identity. We know what cosine squared plus sine squared is. What's cosine squared plus sine squared? Well, that's 1. And so r squared times 1 is just r squared, which brings us to our final step, which is you are going to solve for r squared, r, or theta, whichever one is most appropriate. In this case, r squared equals 20. We've already got r squared, so we're going to leave it there. But say there was, maybe this was 4r squared equals 20, well, we'd divide the 4 over to the other side, something like that. R squared plus 2 equals 20, we'd subtract the 2 over. Okay? Okay, so I'm gonna encourage you at home, if you need to maybe watch one more, but honestly, like, you're gonna wanna pretty quickly start practicing these on your own. There's not a ton to them, so pause the video, try number 2 on your own, restart it so you can check your work, or get a little bit of help if you get stuck. Final thing on number 1 before we proceed and you pause the video and try number 2. I know some people might have seen it at the beginning, but there is another way of solving this problem. Okay? X squared plus y squared at the very beginning, we actually know what x squared plus y squared is in our polar and rectangular equations. Look up at the top of your paper if you didn't catch it. X squared plus y squared equals r squared. So actually, technically speaking, you could have substituted that r squared right into the x squared plus y squared and gotten r squared equals 20. The only reason I don't go with that as the first go round is because not every problem is going to have x squared plus y squared, but every rectangular equation will have an x or a y. And so this, sometimes both, and so this idea of substituting r cosine theta or r sine theta in will always work. You won't always be able to get it to say x squared plus y squared equals r squared. And the dangerous thing is, I've seen it happen, so you want to be careful. It's very tempting to see x plus y and substitute r. But these two sides, if you square rooted both sides, you would not get x plus y equals r. Yes, if you square rooted this side, you'd get r. You would not on this side. This x squared plus y squared, square root of it is not x plus y. And so I tend to recommend, if you're at all feeling like I might make that error, then always just substitute in for x or y, because it'll always work that way. Okay? Okay, go ahead and pause the video, give number 2 a shot, restart it when you're ready. Okay, so we have y equals 4. Again, first step, we're going to substitute. So in this case, I only have a y, so I'm only going to be using this r sine theta, because that's what goes in for y. Go ahead and substitute that in. Okay, and then step 2, you're going to go ahead and look to rewrite. So simplify, factor, Pythagorean theorem. I'm looking at this going, well, there's not really anything else I can do. There aren't even 2 terms in order to factor. I can't rewrite sine as anything. You know, tangent, I could maybe rewrite as sine over cosine, like that kind of thing. But sine, it can't be rewritten. And that's definitely not a Pythagorean identity that I know. So my second step must be done, because I don't see anything else that I can do there. And so then my last step comes in. We're going to go ahead and solve for r squared, r, or theta, whichever one's most applicable. In this case, we're going to be solving for r. Well, how do we get that r by itself? Okay, we're going to go ahead and divide that sine over to the other side, which is 4 divided by sine theta. Or we do know how that sine theta can be rewritten. What is over sine theta equivalent to? That'd be cosecant theta. So r equals 4 cosecant theta. Okay? Okay, number 3, go ahead and pause the video, give number 3 a shot, restart it when you are ready. Okay, so number 3, we're looking at y equals negative x and trying to solve from there. Okay, so substituting in y and x, y is r sine theta, x is r cosine theta. So we're going to go ahead and plug r sine theta into y and r cosine theta into x. Okay, next step, we're going to go ahead and rewrite, simplify, factor, Pythagorean identity, something along those lines. And so immediate kind of look at this particular one, there's not really anything that jumps out at us necessarily for solving here. Potentially speaking, you could try adding the r cosine theta over maybe as a first start. That'd be a good thing to try initially. But when all else fails, then you're going to be sitting there going, okay, well, let me go ahead and then solve for r squared, r, or theta, whichever one is most applicable. And in this case, the first thing we'd like to be able to do to solve for either r or theta would be to get these onto the same side. And so I'm going to go ahead and divide this r cosine theta over to the other side. So make sure to do that in red so we see that that's a step. Okay. And so the r's are going to cancel. Sine divided by cosine is tangent. And then the r cosines are going to simplify to -1, which tells me that I'm now going to be solving for my theta in this particular case because I obviously don't have another r, and so there's no r to solve for. So the question is simply, well, what would be, or if tangent theta equals -1, what would theta equal? So go ahead and take a moment. Tangent theta equals -1, what would theta equal? Okay, well, tangent equaling 1 would be pi over 4, and you could do that either with your triangles, your hand trick, or memorizing the unit circle, whichever one you chose back in Unit 8. So we're looking at some sort of pi over 4 angle. The question is which one would give you -1? Well, tangent is negative in the second and fourth quadrant, and so the fourth quadrant would be -pi over 4 for your theta. Okay? Okay, last but not least, number 4, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so we've got x's and y's here. X, remember, is r cosine theta. Y is r sine theta. So we're going to go ahead and substitute in. The 3x is r cosine theta. Minus 5y is r sine theta. Plus 6 equals 0. Okay, rewriting, cleaning this one up, looking at this. Not really seeing a whole lot that we can do, but I see a 6 that I could subtract over, so let's go ahead and do that. Which is handy because in subtracting that 6 over, look at what I am left with on the left side of my equals there. I've got 2 terms with a GCF of r. I can factor. I can factor that r out. Which will now allow me to do my last step, which is solve for r squared r, or theta. In this case, it's going to be very easy to solve for r, because when 2 things are multiplied, how do you get rid of that other term? You divide it over, and so r equals -6 over 3 cosine theta minus 5 sine theta. Okay? Okay, so that is, again, moving rectangular equations into polar, and I know that these are some very broad steps. Again, not every problem is going to hit every single one of those ideas. They're just overarching concepts that you want to keep in mind, ultimately speaking, aiming for that same end goal with each one, which is to get your equation to say r equals, r squared equals, or theta equals, whichever one is the most applicable. Okay? Okay, if at this point you're sitting there going, okay, I think I'm getting it, I'm good to go ahead and proceed with the video. If you are sitting there going, I think I'd like to do a couple more of those, pause this video, go over to the extra practice video for converting from rectangular to polar, hammer out a couple more of those, and then come back and do this once you're good with converting from rectangular to polar. Okay? Okay, so the second page we are going to be looking at going the reverse direction, which is from polar into rectangular. And so we've got 2 notes up here at the top that I want us to add in. First off, our goal with part A here, converting the polar equation to rectangular form, our goal is to try to get an r squared. And sometimes you won't be able to, sometimes the r will go away altogether. but that's kind of always our focus. Is there any way that I can somehow get this to be an r squared? Additionally speaking, I would throw in that you're wanting things to be in terms of cosine and sine as much as possible, because over here we have two cosine and sine relationships that we can also use. So I'm going to go ahead and put these in blue. Use to replace trig. Okay, our first step for a lot of these is going to be to replace the trigonometric function, and so we want to see things in terms of sine and cosine so that we can take either x over r or y over r and put them into their respective trig. And as we already talked about at the beginning, we use these two relationships primarily for converting from polar to rectangular. This one, if we can get an r squared successfully. This one, usually when there is no r. Okay? Okay, so we're actually going to do number 7 first on this one. Oh, sorry, second note, I almost forgot. When it comes to part B, sketching the graph for your polar equation, you are going to use your converted rectangular equation. We do not expect at this point that you know how to graph using the polar equations. You'll be looking at that next week. So today we are just going to graph using our rectangular equations, the ones we're more familiar with. Okay? Okay, so number 7 is going to be up first. We're going to do part A initially, which is to convert into our rectangular form, to take our polar and convert it. Okay, so in this case we have a theta equals 5 pi over 6, and so again you're keeping these notes in mind. I'd like to be able to get an r squared if at all possible. Unfortunately, this one doesn't even have an r. It also doesn't have a cosine or a sine, and so that's, like I said several times now, is where we usually use this last relationship, which is when there is no r, we're going to go ahead and use tangent theta equals y over x. Okay, and so let's go ahead and take a moment and take the tangent of both sides. Tangent theta equals tangent of 5 pi over 6. Okay, go ahead and take a moment, figure out what is the tangent of 5 pi over 6. Okay, well 5 pi over 6 is in the second quadrant. Tangent is negative in the second quadrant. And this is a pi over 6 angle, so whether you use your triangle, your hand trick, or the unit circle, the tangent of pi over 6, or in this case 5 pi over 6, is 1 over root 3. And so we're looking at 1 over root 3 here. Okay? And then we're going to go ahead and substitute in, because we want to get this into rectangular form, so we don't like our thetas and r's, we want y's and x's. And so tangent theta is y over x. And then the last step for each of your problems, your goal is to then manipulate your rectangular form into something that you can successfully graph. Whether that's a linear form or a complete the square for a circle or a parabola of some sort. Again, you're manipulating to get it into a form you can graph. And so in this particular case, this one is a linear form, and so we're going to get this to say y equals. Well, how do I get this to say y equals instead of y over x equals? I'm going to multiply that x over to the other side. Okay, before we look at graphing this, we're going to go ahead and write down some steps for ones like this one. There's only one in the notes that is in this form, because honestly, when it's a theta equals, it's going to follow a very similar set of steps every single time. And so we only put one in the notes, but again, you can do some extra practice if you'd like. But I wanted to do this one first because it has kind of its own unique set of steps, where the other ones you're going to see, I'd say, a more similar line of steps that you're going to follow. So for this one, when we notice we have no r, our first step is going to be to take the tangent of both sides. That's to get it into that tangent theta form that I know I can substitute into. Okay? And then we are going to go ahead and substitute. So I'm going to call it replace the trig, because you're going to hear that step with the other ones. replace the trig. In this case, it's the tangent theta equals y over x. We're plugging y over x in. And then for these ones, we are going to solve for y, because that will allow us to graph. Okay? So again, when there is no r, when it's just in terms of theta, these, I'd say, for the most part, are going to be your steps. Okay? And then B, graphing. B just gives us a chance to review different types of graphs, some of the ideas that we look at as we are graphing. In this particular case, again, it is a linear. This is y equals mx plus b. And so you can pull out the pieces you need to graph your line. What would be your b in this case, or your y-intercept? Okay, well, our b in this case, or our y-intercept would be 0, right? Y equals mx plus b. And then what's your slope, your m? Your m is negative 1 over root 3. So this is down 1 over root 3. Down 1 over root 3. And again, we don't know exactly what root 3 is, but we know what root 4 is. So if this was 1 over root 4, this would be down 1 over 2, because that's what root 4 is. So this is down 1 over a little less than 2, right, because it's root 3. I don't remember exactly what root 3 is. I think it's around 1.7. You could look it up if you wanted to, but I'm going to go down 1 over a little less than 2. And there you've got your slope. Okay, so just a little graphing review. And you'll see that little graphing review with each of these. Okay? Okay, so the next 4 we are going to do are 8, 5, 6, 9, which I'd say are going to have more similar steps to each other than to number 7, although you'll see some ties to number 7 for sure. With these other ones, for the most part, I'd say our steps, generally speaking, although I'll have a couple of kind of clarification ones as we work through them, are going to be to rewrite and replace the trig. So kind of what that second step on our previous problem was. So we're going to be looking in this one. Oh, let me get that over on the screen there for you. Sorry about that. Rewrite and replace the trig. We're going to be looking at, with this step, like our second step here, getting this into one of the trigs we know. For these ones, it's primarily speaking going to be cosine and or sine. So if you can get it to say cosine theta, or if you already see it as cosine theta, you're going to put x over r in. If you can get it to say sine theta, or you already see it as sine theta, you're going to be plugging y over r in. Okay? And then you are going to manipulate, and again, I'll clarify this as we continue, but you're going to be manipulating to solve for your r in this particular case, or r squared as much as possible. So manipulate. I'm actually going to say manipulate to say isolate r or r squared. Ultimately speaking, our goal is to be able to eventually get to that r squared in this particular case, in order to substitute our x squared plus y squared in, if at all possible. But we're going to be manipulating, so that might mean multiplying by a denominator, or adding or subtracting things, whatever it is you need to do, again, to get it into that form where we can get all of our r's to potentially be r squareds that can then become x squared plus y squareds. Okay? And then solve for a form you can graph, which I know is a very broad idea. This could be a line, it could be a circle, but anything that you can plot points on and somehow get that graph. Okay? Okay, so part A with number 8 here, we're going to go ahead and start with rewriting and replacing the trig. Again, we're looking for sines and cosines that I can replace, and unfortunately I don't have a sine or a cosine in this one, I have a cosecant. So what could I do to get a sine or a cosine? Okay, well I can rewrite that cosecant. That cosecant is the same thing as 1 over sine. And so now I can replace the trig. Sine theta is y over r. Okay, and so that's step 1. Again, you're looking for sines and cosines that you can replace. Okay, step 2, you're going to manipulate to isolate your r. Ideally speaking, you're ultimately looking for that r squared as much as possible. And so in this case, to isolate my r's, I've got an r on the left, I've got an r on the right. I'd like to be able to get them together so I can work on isolating the r. So let's go ahead and multiply this y over r to the other side. And so we have y over r times r equals, and 4 is left on the right. Well, what do you know? In this particular case, my r's actually end up simplifying. And we've got y equals 4, so I'm actually good to go. I don't need to worry about an r squared. My r goes away altogether. But again, if I still did have an r on that side, my goal, and you'll see this in the next couple, is to get an r squared so I can put x squared plus y squared in. In this case, the r cancels itself out. And so I'm looking for solving for a form you can graph. Well, can we graph y equals 4? Yeah. So you're good to go. You're done. You're just going to go ahead and graph this one, B. What does y equals 4 look like again? Just a horizontal line, right? For every x, y is 4. So when x is 0, y is 4. When x is 1, y is 4. When x is 2, y is 4, etc. Okay. Okay, we're going to number 5 next. Okay, so number 5, go ahead and take a moment. Maybe pause the video, start trying some of these on your own, or at least getting as far as you can through it, and then restarting it as you are ready to check your answer, or get a little bit of help if you get stuck. Okay, so first up, we're rewriting and replacing the trig. So in this case, I directly see my trig. Cosine theta is already there, so therefore I can replace that cosine theta with x over r. Okay. R equals 2x over r. Okay, and then again, we're going to be step 2 then, manipulating to isolate our r. Again, ultimately speaking, looking to get that r squared, hopefully. And so in this case, to isolate our r, we've got an r on the left, an r on the right. It'd be nice to get those together, so let's go ahead and multiply the r on the right over to the left. So we have r squared equals 2x. Okay? Well, then what do you know? We have an r squared already, and so we are good to go. I know what r squared is. R squared is x squared plus y squared. Again, that's our goal, right? Manipulate to isolate r, ultimately speaking, looking for the r squared, trying to get that so we can put x squared plus y squared in. Okay? And so we're going to put x squared plus y squared in here. And then our final step, because we are in rectangular form now, we are going to be solving for a form you can graph. And so in this case, we have an x squared and a y squared, so we actually know what that is. What type of shape is that? Okay, that's a circle. Remember, circle has the x squared and y squared, neither one with a leading coefficient. They do have leading coefficients. They're hyperbolas or ellipses, depending on what's in between, or if they have a matching leading coefficient, I should say. Okay, but in this case, this is a circle, and so we're going to be using a similar thought process to what we reviewed back here, and maybe you did the extra practice video for completing the square. We're going to go ahead and work on completing the square here. So let's go ahead and get our x's on one side. I'm going to subtract that 2x over. Any coefficients on the other, which in this case is just going to be the 0 that's left when I subtract the 2x over. And your question is, well, what goes into that space? Okay, remember it's half of this number, so it'd be -1. squared, which is positive 1. And if you add 1 to one side, you have to add 1 to the other. Okay? And so this factors to x minus 1 quantity squared. And then plus y squared equals 0 plus 1 is 1. Although again, because we know we're going to be graphing this, like I did back here, I'm going to, instead of writing it as 24, I wrote it as root 24. Instead of writing it as 1, I'm going to write it as root 1 squared, which we know what root 1 is, right? What is root 1? It's 1, right? So I'm going to write it as 1 squared because that's what root 1 is. Okay, and so then B, we're going to go ahead and graph this. Reviewed this on the front page one more time, graphing your circle. Your HK is what's inside, or I should say your center is the HK inside of your two quantities. So down here for this one, my H would be 0, my K would be 3. And then your radius is what's being squared behind. And so in this case, what is your HK? 1, 0. So that's going to be my center is at 1, 0. And then what's your radius? Your radius is 1, and so we're going to be going 1 in every direction for our circle here. Okay. Okay, number 6, again, pause the video, try number 6 on your own, see how far you can get, and restart the video when you either have an answer or are stuck and need a little bit of assistance. Okay, number 6, first step, we want to rewrite and replace the trig. Well, there is no trig in here. So step 1's already done. There's no trig to replace. And so we're on to step 2. We want to manipulate to isolate r, ultimately speaking, looking to get r squared. Well, I've already isolated r. So half of step 2 is done. Ultimately speaking, our goal is to get r squared here. So how can I get r squared? Okay, well, if I square both sides, r squared equals 25, right? Or 5 squared, which is 25. Well, now I've got r squared. And so I can go ahead and substitute. Remember, x squared plus y squared equals r squared. Okay, last step, you are going to solve for a form you can graph. In this case, that is a circle, right? We've already got it. Don't even have to do any complete the square on this one. Number 6 actually ends up being a little bit simpler in terms of amount of work than number 5. Okay, so we're going to go ahead and pull out our HK. What's our HK in this particular case? Our HK would be 0, 0. And maybe you don't like this written as 25. Maybe you do want to take a moment and rewrite it as r squared to help you with your graphing. What would your r be in this case? Your r would be 5, so you're moving out 5 in each direction. Okay, and you've got your circle. Okay. Okay, one more. Number 9. Number 9, in my opinion, is probably the most challenging of the lot. After number 9, you will have to make a decision. Do you feel like you're good to go with this, or do you want to, at the end of this video, go ahead and go over to your extra practice and do maybe some more manipulation from polar to rectangular? I know this is the one that's going to be the trickiest at first, because it's a new form. We aren't used to working with polar. We're very comfortable with rectangular, and polar gets a little funny. So you might want to do some extra practice, just like you would in class. Right? When your teacher asks, hey, do you guys want to do another one of these? If you were someone who would raise your hand saying yes, or give a thumbs up if that's what your teacher does, or whiteboards if that's what your teacher does. If you were someone who's sitting there going like, yeah, I'd like to do some extra practice in class, well, do that extra practice. You're just doing it at home, right? And then any extra questions you still have at the end of this problem related to the lesson, related to any of the extra practice videos, the homework help video, reach out to your teacher. We're still here to help. We are here to answer whatever your question is or whatever your hiccups that is still there after watching the notes video. Okay? Number 9 is going to be our last one. Go ahead and pause the video, give it a shot, and restart it when you are ready. Okay, number 9. What makes number 9, I'd say, especially challenging is there are multiple ways through the problem. Some easier than others. I myself, working through it, found 2 different ways that I'd say are relatively equivalent. I'm going to work through it one way on this video, but if you did try it another way, it's not necessarily wrong. If you aren't sure how to kind of get the right answer going your route, maybe snap a picture of it and send it to either me or Mrs. Pape. Ask us to help you kind of get there. If it is a wrong route, we'll help guide you to the right route. But there isn't one way through this problem. Okay, in this one, number 9, our first step, remember, is to rewrite and replace the trig. And so we're going to go ahead and take a look at this one. Rewriting, I'm going to multiply my 1 minus sine theta over the other side. Right? So we're multiplying that 1 minus sine theta over to the other side so that we are left with distributing the r minus r sine theta equals on the right side 3, and that's going to allow me to replace my sine theta here. Sine theta, remember, is y over r. Okay? The other option, or the other route that I found, just going on record, because that might have been the route you tried, and again, take a picture if you didn't get the right answer, we'll help guide you, is plugging the y over r immediately into sine theta rather than multiplying the denominator over. There is a way to go that route. It is not wrong. It is just different, right? But I like this route only because in multiplying this over and then substituting in for sine, my r's are going to be able to simplify. Okay, and so I'm left with r minus y equals 3. Okay, and so then second step, we're going to be manipulating to isolate r with the ultimate goal of getting r squared in this one. And so that means isolating r, adding the y over. We have 3 plus y, or y plus 3, which however you prefer to write it. And then how do we get this to be r squared? Well, we square both sides. So this is r squared equals, go ahead and write that squared. Squaring this, it would mean foiling, right, expanding it. So this would be y squared plus 6y plus 9. Okay? And now we're going to go ahead and be able to plug in for our r squared. X squared plus y squared equals y squared plus 6y plus 9. And then our final step is we now need to solve for a form you can graph, or we can graph. In this particular case, I don't know what this is, but I noticed that I can simplify those y squares. Those are like terms, I can combine them, right? So if I subtract this y squared over here, what I'm left with is x squared equals, subtracting the y squareds, they cancel, 6y plus 9. And that looks like a form we did review. On the very front page, at the very beginning of this video, we reviewed how to graph a parabola. A parabola, reminder, is y minus k equals a times x minus h squared. We know this is a parabola because it has only one squared, right? So the goal is to get it into that form. So we want, first of all, our a to not be with our y. We want this to be y equals. We want the a over here with our squared component. And so I want this to be y equals, I want that 6 to go over with the squared component. And so let's, actually I'm going to go ahead and take a moment and just flip this real quick. 6y plus 9 equals x squared. Let's go ahead and factor that 6 out just like we did the 4 over here, right? So we could get it to be y equals, not 4y. I want this to be y equals, not 6y. So factor that 6 out. And that will allow us to divide the 6 over to the other side. And we've got our parabola form for part B, our sketch. Okay. Okay, so first up for graphing your parabola, your HK. H is with the X, K is with the Y, right? That's your vertex here. What would your HK be? H would be 0, K would be -3/2 or -1.5. And then depending on how you liked thinking of graphing parabolas, you might think of it as doing your A movement, a reminder that the A movement only works for one point following your vertex on either side. For others, you did, when you learned to graph parabolas, you would have done like a little XYT chart for yourself and maybe plugged in -1 and 1 to see what you get. So you plug in -1 here, get 1/6 and subtract the 3/2. Maybe you do something like that. If you aren't comfortable plugging in -1, 1, maybe you do -2, 2 or -3, 3. Doesn't matter, as long as you get a couple of other points to help you with the sketch of that parabola. Okay? For me, when I graphed it, I did plug in -3 and 3 myself, only because I noticed when I plugged in 3, I get 9/6, which is 3/2. And when I subtract 3/2 over, that means Y is 0. Same with the -3. And so because those jumped out at me as relatively easy points to graph, those were the ones I chose. But again, nothing fancy about those points, as long as you can get your sketch of your parabola. And one more quick little review reminder, we know this is an upwards faced parabola because my A is positive. Okay? Okay, so that's converting between polar and rectangular equations, and I know there's a variety of this type of problems, so you have to be okay with a little bit of experimentation. Every single problem is not going to be exactly the same. And maybe you want to go over and do some extra practice at this point. Again, there's extra practice for each of the 3 things that have been part of this lesson. And then one more time, if you have any questions, reach out and let Mrs. Papin know. Okay? That's 10.2.